Welcome back to All This Math. This is Professor Parker and Habari Yanni. This is day 4 of Kwanzaa. So today we're going to do some Kwanzaa math dealing with the fourth principle of Kwanzaa from the Nguzo Saba, Ujamaa, which means cooperative economics. Cooperative economics, which is a very important concept in our community. Actually should be an even more important concept, as many of us have been conditioned into rugged individualism and not cooperative economics. We've often been conditioned into or toward individualistic economics, which long term doesn't work even for the individual. But at any rate, you notice I got my Norfolk State sweatshirt on, not because I attended Norfolk State, because I didn't, but as kind of an homage to Michael Vick. Michael Vick was just named the head coach of the football team down in Norfolk State, so shout out to him. Shout out to Norfolk State for going to get that talent, and hopefully there's a positive influence on the football program down there. Now let's get into the problem we're going to do. Now the problem we're going to do is a word problem, but it's kind of lengthy, so I wasn't going to write it on the board. You can find the actual word problem printed in the description underneath of the channel. Also, make sure you subscribe to the All This Math YouTube channel. Make sure you like, subscribe, and share the video, and drop a comment down below if you feel the need to. All right. I'm going to read the problem, though. I'm going to read the problem. All right. And in doing this problem, we're going to model cooperative economics, right? We're going to show how algebra and personal finance is directly connected into cooperative economics. All right. Well, not personal finance. It's really group finance or group economics. All right. So the problem reads like this. Some good folks on the south side of Chicago decided to start pooling resources to start a grocery store co-op. They want to start a grocery store co-op that's community controlled. They raised $60,000, $60K, and they want to earn, or they want or need to earn $3,200 in a return on the investment in a certain period of time. The funds will be allocated in two ways: in a money market account, which earns 4% interest, and a mutual fund, which will earn 6% interest. The question is this: how much of the original investment, which is the $60K that the community already pooled and already saved up and put together, right? How much of the original investment needs to be allocated into each investment vehicle in order to earn that $3,200 return? So this is a typical question you might see in a finance class, right? There's also a question that involves algebra, right? And it also does involve finance. So when people say that schools should actually get rid of algebra and replace it with finance, this is just another example of why that request doesn't really make sense, because you still require algebra in order to do actual finance problems. So algebra and finance are really one and the same. There is no one without the other. There's no finance without algebra. There isn't. So we have to be more clear about that. Now, what we could say is that in the schools, you might want for there to be more applications of finance in the algebra coursework. You can say that. That makes a lot of sense, right? Or what you could do is find independent resources that you can use in order to teach your children that on your own. It's up to you, such as the All This Math YouTube channel, which is an independent resource that you can use to teach your children these things on your own, regardless of what the school might be doing. All right, so how are we going to set this up? So let's first write down some information. We know we got, let me use this black marker. We know we got $60,000, right? So that's going to be, we'll write down 60K. And we have a money market account, and we have a mutual fund. All right. Now we want to know how much money from the 60K is going to go into the money market account, and how much money from the 60K is going to go into the mutual fund. So let's say the money market account was X, right? The amount of money is X. And the mutual fund would be Y. We could say Y, but I'm not going to say Y, because I want to have one equation that's in terms of one variable. So if the whole amount is 60K and X of it is in the money market account, MMA, even though those M's look different, I don't know why I did that. The mutual fund has to be whatever's left over. So how do you figure out whatever's left over? You take the whole 60K and you subtract however much is in the money market account, which is X. So that would look like this: 60K minus X. So we got X and we got 60K minus X. X and 60K minus X. This is very important. Identifying your variables when you're dealing with any type of word problem is very critical. That's very important. All right. So then we're going to set up an equation. Once we got our variables and our variable expression, we're going to set up an equation. So we know that the money market account, based on the information given to us in the problem, is paying 4%. So we're going to have 4% times the money market account plus 6%, because the problem tells us that the mutual fund is paying 6%. So it's going to be 6% times the mutual fund. And we need that to equal $3,200 because they need to have a return of $3,200 for whatever reason in a certain period of time. All right, so this is our original equation. Now we're going to replace this with a variable expression. And we're going to replace this with a variable expression. And we're going to switch these 4% and 6% values into decimal notation. Now, how do you change a percentage into a decimal? You take that number and divide it by 100. The shortcut is you take the decimal point, in this case, the invisible decimal point right after the 4, move it 2 spaces to the left, not to the right, to the left, not to the right, to the left. And you say, well, there's a blank space right here. What are we supposed to do with that? You put a placeholder, a 0. So it'll be 0.04, 0.04. So this is going to become 0.04 times X, why X? Because we're representing the money market account money as X. Then you put your plus sign. You change 6% into 0.06. And then you're going to change the mutual fund into 60K minus X. So I'm going to write this out. 60,000 minus X is equal to 3,200. All right, so that's our equation, right? That's our equation with all our values in place. So then we're going to simplify. And our goal now we're just doing algebra. Like remember I told you, in finance, we use algebra all the time. And I should know this because I got a finance degree from Morgan State University. And in my finance classes, we use algebra all the time. So again, if you're one of these people that's saying we should get rid of algebra classes and replace them with finance classes, you can't. It's not possible. You need algebra in order to do finance. All right. So now we got 0.04x, because 0.04 times x is just 0.04x, or 0.04 times x. Then we're going to distribute the 0.06 to both of these inside the parentheses, both of these, this and that. So 0.06 times 60,000. I could grab my calculator and do that, but I'm not even going to do that. What I'm going to do is, since I know that that's 6%, I can figure out what 1% of this is and then multiply that by 6. Because 1% times 6 is 6%. Follow what I do. I'm first going to figure out what 10% is. To get 10% of any number, you just move the decimal point 1 space to the left. So this invisible decimal point right here moves 1 space to the left. So 10% of 60,000 is just 6,000 or 6 racks. 10% of that would be 1%. So 10% of 6,000 is $600. That means that 1% of $60,000 is $600. So basically all I did was move the decimal point 2 spaces to the left. 1% of 60,000 is $600. Now, why did I want that? Why did I want to even know that? Because once I know 1%, I can figure out 6% by taking that number and multiplying it by 6, since 1% times 6 equals 6%. So if 1% is $600, all I got to do is do $600 times 6. Now, 6 times 6 is 36. You should know your multiplication facts, so you can know that off the top of your head without a calculator, without thinking about it. If 6 times 6 is 36, 600 times 6 is 3,600. So 6% of 60,000 is 3,600. And then we got minus 0.06x, just like we had 0.04x. We got 0.04x, we got 0.06x. 0.06x is equal to 3,200. Notice the 3,200 ain't changed. The 0.04x is over here. So now we're doing algebra. We're going to combine like terms. What are our like terms? We got an x term and an x term, an x term and an x term, an x term and an x term. Put them together. You put them together, we end up with negative 0.02x. And then we still got plus 3,600. We still got plus 3,600 equals 3,200. Right? So now again, we solving for x. So we're trying to isolate x by itself. Isolate x by itself. So we're going to get rid of 3,600 on the left-hand side. We're going to get rid of negative 0.02 on the left-hand side. We're going to get rid of 3,600, and then we're going to get rid of negative 0.02. How do I get rid of 3,600? I do the opposite operation. Opposite operation. Subtraction is the opposite of addition. That's a plus sign. Addition. Opposite is subtraction. So on the right-hand side, I got negative 400. Negative 400. So I bring this down. I got negative 0.02x equals negative 400. Now, how do I get rid of negative 0.02? I do the opposite operation again. This means multiplication, not because it's an x. The x is the variable, not a multiplication sign. But because there's no symbol in between that decimal and the x, that means that multiplication is taking place. So you do the opposite operation. The opposite of multiplication is what? Division. We're going to divide. Divide by 0.02 over here. Divide by 0.02 over here. So we got that. We got that. And we got x is equal to, now again, 0.02 is 2 cents. Imagine this was $400, right? And 0.02 is 2 cents. So the first thing I might think about if I'm trying to do this mentally without a calculator, I could grab a calculator, but I don't feel like going to grab one. And I don't need to. 0.02 is 2 cents. So how many times does 2 cents go into $1? 50 times. Because 2 cents times 50 is $1. 2 cents times 50 is $1. Right? So that's 50. But then I got $400. So I got to do that 50. 2 cents goes into $1 50 times. Then I got to do that 400 times. So that's really 50 times 400. 50 times 400. So what does that look like? 5 times 4. 5 times 4 is 20. And then what do I do with these zeros? You attach them to the 20, giving me 20,000. So that means that 0.02 can easily fit into 400 20,000 times. So 2 cents can fit into $400 20,000 times. So that means that negative 400 divided by negative 0.02 equals positive 20,000. Why is it positive? Because whenever you divide a negative by a negative, your quotient is always positive. That's why it's positive. So we got x equals $20,000. Now, what was x from the beginning? From the beginning, the money market account money was x. So that means that out of this 60,000, 20,000 needs to go in the money market account. And then for the mutual fund, 60,000 minus the 20,000, because that's x, 40,000 needs to go inside the mutual fund. This is the answer to the question. So see what we did? We used algebra to deal with cooperative economics, to deal with the finance behind and the details behind Ujamaa or Ujamaa in cooperative economics. All right? Because the community, the people, and the situation I created in the scenario down on the south side of Chicago, they want to start a grocery store co-op, and they put their money together, and they said, all right, we got 60,000, and then we want to invest it so that we can have a return of 3,200 for whatever reason. But how do we allocate our funds? How do we allocate the 60,000? All right. So if we allocate it this way, at these rates, at these percentage return, these return rates, 4% and 6% respectively, we need to put 20,000 of that 60K into the money market account, and we need to put the other 40, the remaining 40,000 into that mutual fund that was also identified. All right. So see what we did? We're using the principles of Kwanzaa from the Nguzo Saba, Ujamaa, Cooperative Economics, and we're showing the math. We're showing the math, the connection between the math, the real life connections to the Nguzo Saba. So we don't gotta just talk about Kwanzaa in December and then don't talk about it again till the next December. We actually can implement and utilize and apply the principles of the Nguzo Saba on a regular daily basis whenever we're dealing with math that deals with economics, finance, and so on and so forth. All right. So hope that made sense. If it didn't, just run the video back. Just run the video back. And also, you can create other scenarios on your own. Create other scenarios on your own, do the math, do the practice, and until you develop your fluency. And this is also meant to help you practice algebra, because algebra is a very important tool that we need so that we can be able to solve certain types of problems. All right. I'll see y'all later. Peace.